Let's move into the demonstration, and the first demo I want to do is actually implement network time protocol on our routers. To implement NTP and syslog, I've set up this lab for us, and let me give you some information about the lab, and then we can go about setting up syslog and NTP on it. So first of all, what I have is routers A, B, and C. I have a network connected to each one. My workstation is in that upper left-hand corner at 10.0.0.10. And then I have some other networks set up. I have all three of these routers set up with OSPF, and router C is connected to the internet. I had to set up network address translation on that device. We're going to learn how to set up network address translation to connect to the internet in a couple more courses. For the time being, I set it up so that we could get out to the time.nist.gov servers. Additionally, I want to show you how we can download a syslog software, so we'll need to be connected to the internet. I have turned on OSPF on all of these devices so that each device has a complete routing table and can ping every other device on the network. There is one caveat to this. The internet connection is going to operate extremely slow for me because I am using the serial connections to connect router A to B and B to C. Because of that, those connections only operate at like 64 or 128 kilobytes per second. So that's like dial-up speeds for internet. Modern websites can't typically handle that. So I'll point out when I'm surfing the internet directly and when I'm pulling a file down that I had downloaded previously on a faster connection. So let's go on to my workstation. We're going to SSH into router A, B, and C and configure the clock and network time protocol. So I'm at my workstation now. My workstation can ping out to the public internet. So I can ping Google at www.google.com and I get a response, which means that I'm connected to the internet. If I do a ping to time.nist.gov, what that will do is show me the IP address of my nearest time server. This time server must not be configured to respond to ping messages, but all I needed here was this IP address, 24.56.178.140. Let's SSH onto router A and start to configure network time protocol. So we'll start our SSH session by going to 10.0.0.1 and we'll log in. Go to privilege mode, and what I can do is issue the command show clock. Let's make that full screen. Show clock, and that'll tell me what time it is currently set to. And right now it is set to 6:25 a.m. on January 10th, 2001. Well, I can tell you right now, today is not January 10th, 2001. So let's do a few things and get our time server configured, as well as the time zones that we need. We'll move into config T, and what we want to do is set the time zone that we're currently in. So the way I do that is I issue the command clock, then if I hit question mark, it's going to say, well, what do we want to do here? We want to do the time zone. And then it's going to say, what word do we want to call this? Now, we have some standard time zone names, but you can create your own name here if you want. The time zone that I am in is Central Standard Time, CST. And that's just a name. What it needs next is, what's the offset from UTC? And we looked up that offset in the chart, and it's -6. So my offset's -6. Now I've just set my time zone to be the Central Time Zone in the United States. Next, since I live in the United States and I live in a state where we observe this crazy daylight savings time, what I need to do then is I need to tell the router to adjust its clock for daylight savings time during the summer. So the way I do that is I say clock, summertime, and then we give it a name again, this time CDT, Central Daylight Time or Daylight Savings Time. And here we can just say recurring, and what that will do is it will use the United States version of daylight savings time beginning and end time, and it will properly automatically now adjust our clock to the right time. Now that we have the time zone set and we have the daylight savings time configured, now we can configure the NTP server. So the way we do that is we say NTP, question mark, and we can say server. What I do then is I go grab that address that I got here from our ping, and I'm going to paste that into PuTTY 24.56.178.140. Once I set the time server, we can do a show NTP, and it should show us show NTP status, and it should tell us what is currently happening. The clock is synchronized via Stratum 2, and it tells us what the IP address is. We're getting our time from a Stratum 2 time server. It tells us a bunch of information about that time server and some delays that are involved in it. And we use all this information to get a very, very accurate time. The big point here is if I do show clock now my clock is set to correctly. It is set to 11:57 a.m. Central Daylight Time on Sunday, October 16th, 2016. That's exactly what time it says on my clock, on my iMac, and on my watch, and on my cell phone right now. So now I have the accurately configured time on router A.